Thank you very much. This is the talk that was written by Phil Rehrig of the American Galvanizers Association. I talked to Phil and he says today is their first major snowstorm in Colorado, in Denver, where he lives. So I said, what are you doing there in the snow? You should be in Sao Paulo. We are looking toward summer and we are not looking toward winter. So I think he wishes he could be here giving this talk today instead of being in the first snow in Colorado. So the purpose of this is to introduce you to the approach to the North American market of the American Galvanizers Association. And then there are two special topics to present to you. One is the result of their life cycle costing model. We have some very interesting results from life cycle costing. And then some of the new case studies, some of the examples of galvanized steel projects in North America. So that will be the organization of the talk. So there are three portions in the first part. First of all, the tools for marketing and training that the American Galvanizers has. Second, the technical tools and training. And third, the administration tools and training. And really these are the tools to operate the galvanizing company as a business. Some of the business things for administration of a galvanizing company. So for marketing tools, first of all, one of the main tools that is used is the Think Zinc seminar. This is a sales and a marketing program, and it is used to present both the basics of the advantages of galvanizing and also the sustainable development to present the sustainability attributes of galvanized steel. So it is a basis of the technology, the technical information of galvanized steel and where it can be used to advantage, and also the life cycle cost calculator, which I will show you an example, will be shown later in this presentation. So these tools are all at the AGA website, which is galvanizeit.org. On there you can find information. They include what they call microsites. Microsites are in specific applications, like the parking garages, like municipal structures and other sites that are very specific to applications and markets. So when they are promoting these different applications, the customer is referred to these microsites. GalvaSource is the internet tool to refer the potential customer to a galvanizer. So it includes things like the kettle size, the geographic location, and other information about the galvanizer to help them source the galvanizer. The knowledge base is really a technical library with information about corrosion performance, painting, all the other good technical information, and also a case study library, because many times people want to be sure that they are not the first person to try to do something. They want to see that somebody has done it successfully before they have done it. So the purpose of many of the activities is to push people to the website. The website is quite good, and many of the tools that are shown to the world are to push them to the website. They advertise galvanizing in many of the magazines, the periodicals and journals for the engineers, for projects, for civil engineering. Much literature is prepared and given at trade shows. Also working with the technical journals to write articles that are put into the journals that are showing the advantages or recent developments for general galvanizing. And the trade shows, they say they are vertical, which means they go up and down the supply chain, up to the suppliers and then down to the customers, and also horizontal across the different means of corrosion protection. So, and we will see some examples of this. The architects and engineers segment, of course, is very important. We must really be sure that the architects and engineers understand galvanizing, and we must be sure that we understand the architects and engineers, knowing why they would choose galvanizing and why they don't when they don't do it. And the communications that are constructed by the American galvanizers are reacting to this understanding and to show why and to understand why not if they have the answer of that they don't do it. The trade shows are done nationally across North America by the staff, and also the galvanizer members are used regionally when there's regional trade shows. And AGA has a standard booth, an exposition booth that can be shipped from their headquarters in Colorado to locations where the galvanizers would want to make an exposition. They just send the booth around, so each company does not need its own booth to present galvanizing. So working with different associations, of course, with the American Institute of Steel Construction, the lobbying with the governments, both on the federal and the state level, and also with the NACE, the National Association of Corrosion Engineers, the Steel Structures Painting Council, and also the Concrete Reinforced Steel Institute, are different committee memberships that AGA works with. The objectives they find, of course, as it's almost a law of nature, that 20% of the people do 80% of the work, so they know which are the 20% of their members who are doing 80% of the work, and they work with them on the seminars, and again, they try to drive the traffic, to drive the interest to the AGA website, which is all the information. The cooperative efforts with the galvanizers allow us to address the competition of paint, of the weathering steel with the high copper content steel, and also concrete, which are really the competitors for general galvanizing. Of course, you cannot get into a trade situation, but the use of fair margins on the reasonably costing and pricing of the project can be addressed in certain ways, and the possibility of showing that general galvanizing is the best corrosion protection system that's available at the best price is part of their objective. So the technical tools and training are working through a main committee, which all the galvanizers can have members belonging to. They address the health and safety issues, environmental issues, processing issues, coating performance, mainly for dealing with customer requests. And every year in October, which means just a few weeks ago, we have the Tech Forum, and this addresses the main technical problems of the industry. Many of the plant operators are coming to the Tech Forum. It includes small groups and also lectures by people. For example, I gave a lecture there last week. There are many manuals, the books to document and teach information. They have a good safety manual to teach the safety in the galvanizing plant, the environmental performance and environmental rules and how to meet them, and quality assurance to teach the quality methods. And of course, they have the electronic information on processing and maintenance, also on safety and inspection. Maintenance includes things like the use of chains or other ways to hold jigs in the bath, the special ways that we are moving work in and out of the bath, how long they are lasting, what are the recommendations for maintenance and the materials for these the special kind of equipment. Technical tools also include seminars, which can be done in the plant. There are 4 modules or sections of the processing seminars on the basics of hot-dip galvanizing, on the use of the chemicals, and the operation and control of the zinc kettle, and also handling of materials, which of course is a very big factor in success or not. And also another seminar only on inspection of the work and the different norms and procedures for inspection. Also working together with other organizations, again, the American Society for Testing and Materials, They have different committees, and the technical director of AGA is also the chairman of the ASTM Committee on General Galvanized Standards, with the Institute for Electronics and Electrical Engineers, again, NACE, the corrosion engineers, the Federal Highway Administration. Of course, this is very important because so much work goes to highway kinds of applications. Also, Department of Transportation, the same thing, and the American Institute of Steel Construction again. So courses are taught that these other organizations, members are promoted to, and they are given this way to learn about general galvanizing. So again, we work with IZA, with AGA on research and development, on supporting different research projects together. A lot of work on corrosion performance, if new corrosion information is needed. Also on some of the chromate-free coatings that have been developed over the years. It was mentioned yesterday about colored zinc. We've worked on some projects like that in the past. The galvanizing handbook we mentioned. And also every year a benchmarking survey is done of the members to understand the levels of productivity, the levels of usage of zinc, of different chemicals, and different practices. So this benchmarking survey is then shared with all the members. The galvanizing notes are on the website. There are many notes to assist in the proper operation of the galvanizing plant, dealing with safety, dealing with many of the chemical controls, how to control skimmings and dross. These are the waste products of the zinc. And again, the guidelines for the use of wire and chain, for air monitoring around the pot especially, and also acid mist, for example, and work in the confined spaces. If you are working in a space that is limited access, the kinds of safety regulations that apply. The committee structure of the members is driving and giving the life to all of these projects, and also it influences the work with the other engineering organizations. Okay, and the next is the administration. The things that are helping here are a newsletter. It's really intended for the president or the administration people of the plant, the newsletter, the benchmarking surveys, things like pricing, and also insurance. Of course, insurance is a major cost to know what is the kind of insurance and levels of coverage and the kinds of pricing of insurance that are used come out of this administration tools. The legal practices, for example, what kind of warranties for the quality of the product, the life of the product. There are warranty guidelines that assist the galvanizer in working with his customer. Things like purchasing procedures, and if there's a crisis, how to have a crisis management plan. Also, position papers. Many times we have to answer to the public. Some of the more common topics are: what is the situation about lead in the galvanized coating? What is the potential for runoff or release of zinc in aquatic systems, for example, from the railing of a bridge into a river? The amount of zinc in soils, the sustainable development issue, and also the welding of galvanized steel, which can occupationally be an issue with the vapor or the fume. For the sustainable development topic, it's interesting that every year, to be an architect in the USA, you must pass a continuing education. You must have a few credits for continuing education. The AGA course on sustainable development with galvanizing is now qualified to give credit to the architects. So in that way, we are making sure that many architects are receiving the information from the sustainable development and galvanizing course. So, of course, we want to speak with one unified voice for the industry. If people make mistakes, we try to learn about them and make sure that all information can be shared with the industry through this AGA. So, the big message, of course, the central message is that hot-dip galvanizing costs less and lasts longer. That's the main message. That is why that's the main message you give about hot-dip galvanizing. So the cost of corrosion protection, we talk here now about the life cycle costing. The first cost is always important. People want to see what they pay at first. The life cycle cost, of course, is more important for the life of the project. We must look at the future maintenance that is required in competitive corrosion systems, which means paint. So the life cycle cost calculator is on the website. If you go to this galvanizeit.org/galvanizing cost, you then have a web-based calculator which allows you to determine the life cycle cost. The information for this, just to give the background, there is a corrosion painting cost survey done every year in cooperation with NACE by the Canadian company KTA Tador, and also a galvanizing survey has been done. So the assumptions, the basic assumption for the calculator is a project of 3,000 square meters, which is 30,000 square feet, in a moderately industrial environment with a usual mix of steel, some structural pieces, some tubes, some plate, the normal kinds of mix of square meters per ton of steel that would be galvanized, or alternatively that would be painted. So the paints that are also used are also, of course, entering into the calculation, and it includes all the labor, the preparation, and so forth that is needed to get the work to the customer. So the results are a little surprising. They show that hot dip galvanizing, which after all has a life of many years, 50 years is not unusual, and this, I'm sorry, is dollars per square foot. But even if we go to reals per square meter, the ranking is the same. If you are making your conversions, the ranking is, there's no change in the order of the numbers, but we just use dollars per square foot here, but it does not change. Inorganic zinc is cheaper. Then you have hot dip galvanizing, and then inorganic zinc epoxy. These are all very near together. If you go more expensive, then you have the more engineered systems, the more durable coatings. But remember that these are usually about 15-year lives for any of the paints. If you have 15 years, you are doing very well. We do have a much longer life with hot dip galvanizing. So even on a first cost basis, hot dip galvanizing is very competitive with some of these paint systems. As we then go to the life cycle cost, then of course you must look at each paint system. We look at the KTA Tador survey. We use 2% for inflation. Again, it's US dollars. 4% is interest, financial interest. So again, it's based on the American assumptions. Of course, the calculator allows you to change the net future value and net present value calculations, so you have a real number for the life cycle cost. And then maintenance repaint at 5% rust for the paint. So if this is not ideal, this is practical. You wait till 5% rust and then you paint. And then for the galvanized in the mild industrial environment, we say it's 50 years life for the galvanized coating. So then, of course, you have these numbers, which are completely in favor of hot dip galvanizing. All of the other coatings, even the most expensive coatings with their longer lives, do have a much higher life cycle cost. And again, the ranking is the same, even though it's dollars per square foot. If you convert to square meters and reals, it's exactly the same ranking. And you can see here the tremendous advantage that we have with hot dip galvanizing. So all this can be changed. The different climates can be put in the web calculator, from marine down to very mild environments, and you can adjust everything to meet your specific need. But this is the result for the assumptions I showed you. And then the total cost of the 60-year project, hot dip galvanizing, and then you must move the column here because it is 6 figures for the most of the numbers. You can see it's $48,000 for the galvanizing, $154,800 for the inorganic zinc, and then the other numbers are higher than that. So there's a great advantage in life cycle costing for general galvanizing. And this we've known for a long time, but now the customer has the power to use the website calculator to go in and really make the calculations themselves, which is the best way of convincing or selling it, is the customer is convincing himself. So finally, we have the galvanized steel projects, some of the recent projects that you also find many more on the AGA website. we have here, this is in Calgary in Alberta. This is in the Midwest of Canada. This is a light rail transit. You have these trackless trolleys with the lines overhead, and this includes the columns, the arms, the light posts, handrails, the benches, and the hardware. And this is in a urban city. It's not very industrial right in the city. Of course, nearby Calgary, you have many big oil projects from the shale rock. They are developing this oil industry near Calgary. But in the city, it is really just an urban environment. And so it's a fairly mild environment. So the advantages of this are shown more in the case study, why it was made this way and so forth. In Michigan, in the north central part of the USA, this is just a bridge railing, a very common kind of construction you find all over the world. So the guide rails are shown, and these are the sorts of projects we follow for many years. In Michigan, they use a lot of salt for ice control. So over its life, we can expect this bridge will see a lot of spray from the calcium chloride, the water that is resulting from the solution of the ice. It will be sprayed many times over its life with the freezing. So this is a severe chloride de-icing kind of environment. This is a museum of the motorcycle company Harley-Davidson in Milwaukee, Wisconsin, which is their home. They have this structure. It's a rather industrial kind of structure with the all kinds of exterior frames that you see in the picture, the I-beams, the structures, the columns, the plates to join things together, cross-bracing to hold everything together. And of course, this must be like any museum. You expect it to be beautiful, and you want it to be beautiful for a very long time. So they chose hot-dip galvanizing for this structure, and of course they will have minimal maintenance. So this is an urban environment again. It sees some de-icing salt, not as much as a highway, but we can expect some chloride contamination of this environment. This is a solar farm in California. This is in the Central Valley. It is a valley which was formerly a farming environment, but now it's become much more industrial. And this kind of solar farm, this is the California desert, and so they have sunshine most days. And the galvanized frames and the galvanized hardware are shown supporting the solar panels here. And of course, you can see the regular transmission tower behind the bottom picture, behind both pictures that you see here. So we are using to promote the idea of these frames for the growing market for the support of these solar panels. This is a bridge in New Jersey. This is a suburban environment. It is not so polluted, but again, in this part of New Jersey, near New York City, they are using a lot of salt for ice control again. So we can expect this bridge will see a lot of ice control and chloride contamination. So all of the trusses, the structural trusses, the floor beams, the diaphragms holding the floor deck up, and the supports, railing, and plates are all hot-dip galvanized in this case. So just to conclude, we have the website of AGA, which is shown here. In the USA, they have a toll-free 800 number. You find on the website the various library and knowledge base. The direct web address for the knowledge base is shown here, and also the newsletter every 3 months is put on the website also. So in this way you can see many of the resources that they have for general galvanizing. So with that, that was what Phil Rehrig wanted to present to you at this time. I'm sorry that I am not him, that he is not here, but I can try to answer any questions about AGA. And if I can't answer them, I will give them to Phil and he will answer you. So thank you very much for your time.
Yes, good afternoon. I would like to know, please, about your website. I would like to know if the access to it is free. And also you mentioned that we have a library in it, right?
Yes.
I'd like to know if inside this library we can have any work done regarding our coast that we know that attacks a little bit our structures. We have towers, installed all over our coast in Brazil, and now the salt, you know what I mean, the salt, the chloride is attacking our towers. So I'd like to know if inside this library you can find any work done or any study done about it.
Okay, much of the information is for general access. There is a lot of open information that you can find. There is some information that is reserved for the members, and I don't know the exact details. If Phil was here, he would be trying to ask you to become a member, I'm sure, but there is much information because let's not forget the main purpose of the website is to bring new customers. So of course they are not members, we just want them to use general galvanizing. So much of the information on the website is open and free. So if I understand correctly, you're asking about the chloride and the severe marine attack. Yeah, so in my speech yesterday about the oil and gas, I showed the coating life, service life for the galvanized coating and how many years you could expect for the coating life in severe marine, and I think we are talking here about a severe marine environment.
Yes, right.
Okay, so then there certainly will be two kinds of things happening. First of all zinc corrosion products are white. If you see zinc corrosion, it's white. So it is only in the case of steel attack when you are really, the coating is failing after long service, and that you begin to see the red rust, which is the attack of the steel. And that is a functional attack, and then it is really a sign or a signal that we really have to pay attention and do some maintenance there. So most of the, in a severe marine environment, it's very usual to have a white rust because this is a very corrosive environment. The white rust also can form, as we heard yesterday, some adherent chloride products. The Simon cholite, which is a very technical name for the compound, and other adherent chlorides actually can help with the protection by these adherent products of the galvanized coating. Most of the reaction and a great deal of the corrosion occurs in the first 2 years until the passivity of the coating then goes for a long time. So unfortunately, this is really an appearance problem where we have the white rust forming, and you might think, oh, it looks terribly corroded, but if you measure the corrosion rate over time, you find that over some years it is a much slower rate than after the beginning, and that really only after you are seeing the red rust start to come that you have the steel attack, which is a functional problem. So
that's good news for me to hear about that. No, after 2 years or so, this corrosion will slow down. This is good to hear.
Yeah.
Let me just ask another simple question. What if I wash this tower, let's say once a year? You think that will help something, just taking out of this salt from the tower? You think this is going to help any way?
Well, it may help cosmetically. As was mentioned yesterday, we have both soluble corrosion products and insoluble corrosion products. So you're not going to take away the insoluble corrosion products unless you really mechanically work at it or give it a very strong acid. So, and you want to keep those. They are part of the passivation, the protective coating. So washing it, you will remove the soluble products and some of the dirt and other things, but that is just going to be a cosmetic factor. I think if it rains, it's going to help you also.
Thank you very much. Bye-bye.
Okay, I'm told that is the end of the time, so I will thank you again and look forward to our further discussions.